Welcome back. Let's go over lesson 6.5, congruent figures. We're on page 328. So congruent figures means they are exactly the same size and same shape. So two-dimensional figures are congruent if there is a sequence of transformations or rigid motions. So a sequence of translations, reflections, or rotations that you can figure out to map one onto the other. So again, figures are going to be the same size and same shape if you can come up with a sequence of rigid motions or transformations to get one to land on the other. Same size, same shape. All right, so take a look at page 329, number 7, up at the top. Okay, so this says triangle QRS prime is the image of QRS after a reflection across the y-axis and a translation of 6 units down. Is the image the same size and shape as the pre-image? Okay, folks, remember that reflections and translations do not change the size or the shape or the shape. They remain the same. So if you flip it and then you slide it into place, it's still going to be the same size and shape. So triangle QRS and triangle QRS prime are the same size and same shape. Reflections and translations do not change the size and the shape. So they are still the same size and shape. Okay, so take a look at number 8. Is triangle DEF congruent to triangle DEF prime? Okay, so that little symbol right there, the equal sign with the little wave on top, that means congruent. So they're asking, are these the same size and shape? Well, if we can figure out a sequence of transformations or rigid motions to get this one to land on this one, then they are going to be congruent. So I'm noticing these are not even facing the same way. So this is going to involve a turn, I believe. So if I rotate this blue triangle DEF 1, 2 times, it's going to land down here, and then I think it's going to be facing the same way to slide it into place. So I'm going to rotate 180 degrees, 1, 2 turns. So if I rotate 1, 2 turns, and remember I could record where these points land. So point F is at -2, -4. And then point E is at 1, 2, 3, 4, 5, -6, -3. And then point D landed at -5, 1, 2, 3, 4, 5, -5, -5, -5. Okay, so then I'm going to rotate this back around and I'm going to graph the 3 points that I just wrote down. So I wrote down angle, or point F is at -2, -4. So that's where F landed. And then I wrote down -6, -3 for E. So -6, -3 for E. And remember, you can do the other method as well. You can do the L-shaped pattern and rotate 2 turns around. I'm just reminding you can rotate your page. -5, -5. So that's D. So it looks like now they are absolutely facing the same way. So now I could just translate 1, 2, so F has to land on F. So let's translate 1, 2, 3 units to the right and 1, 2, 3, 4 units up. Then this will land on this. So that absolutely, let's answer this question. Is this triangle congruent to this triangle? Yes. And because I was able to come up with a sequence. So rotate 180 degrees and then translate. Let's say we said 3 units to the right and 4 units up. 3 units right and 4 units up. Okay, because I was able to come up with a sequence of rigid motions or transformations to map one onto the other. So if you take a look at number 9, describe a way to show that quadrilateral ABCD is congruent to ABCD prime. So these are both laying the same way, but I'm noticing AD, this is on the inside, so they're not quite. I think that if we flipped this blue figure over the y-axis, so this is 3 to the right, let's go 3 to the left, A there, D 3 to the right, 3 to the left, B is 3, 4, 5, 5 to the right, let's go back to the center line, and 5 to the left, B would be there. C is 5 to the right. Let's go 5 to the left. C would be there. So the first thing I did was reflect over the y-axis. Now it looks like I could just slide this down into place and every point will land on each other. So A has to land on A. So if I translate 1, 2, 3, 4, 5 units down, every single one of these points 5 units down, then this will land on this. So it says describe a way, a sequence of transformations. So we would say reflect over the y-axis, then translate, what did we say, 6 units down, I think? 1, 2, 3, 4, 5 units down. Translate 5 units down. That is a sequence of transformations that would map one onto the other. All right, let's do another one. You're making 2 triangular flags for a project and need the flags to be the same size and shape. Triangles are the flags that you drew. Are the flags the same size and shape? Well, folks, if we can come up with a sequence to map one onto the other, then we could make it the same size and shape. So one of the things I could do is reflect over the y-axis to get them facing the right way. So Z is 2 to the left. Let's go 2 to the right. X is 1, 2, 3, 4, 5. 5 to the right. Let's go 5 to the left. And then Y is 6 to the right. Let's go 6 to the left. Now I could just slide this into place and Z will land on Z, X on X, and Y on Y. So one way is that we could reflect over the y-axis and then translate 1, 2, 3, 4, 5, 6 units down and 1, 2, 3 units to the right, 6 down and 3 right. Okay, so one way would be reflect over the y-axis and translate 6 units down and 3 right. That's one way. Okay, could you absolutely have translated 6 units down and then 1 unit to the right? If you slide 6 down and 1 unit to the right, then it'll be like that, something like that. And then you could have reflected over the line X equals 1. You could have absolutely came up with other options. Okay, last one. Take a look at page 330, number 12 at the top. Okay, so are these 2 triangles congruent? Well, if I just check the height, these don't look like they're the same size and shape to me. So if I check the height of this one, this is 1, 2, 3, 4 square units tall. But the height of this one, if we were to measure this height this way and stand it up, this is only 3 units. So these are not the same size and shape. So no, these are not congruent. There isn't a sequence that you could come up with to map one onto the other. I hope that helps.